So in this video, we'll take a look at difference of squares and factoring a difference of squares. Now, a difference of squares is exactly that, a difference or a subtraction between the two of two values that are squares. Now, they might be perfect squares, which makes them very easy to identify, or they might not, and we will have to treat them with square roots. But let's take a look at what happens in the formula, okay? A squared. A squared, what about the square root of a squared? If I square root a squared, we get a, right? So notice that if I have a squared value here, that its square root occurs as the first term of each of the factors. And the second one is b squared. And if I square root that, I get b. And they occur as the second term of each of the factors. In one bracket, we have a sum, and in this other one, we have a difference, and it doesn't matter which order they go in. So let's follow the same pattern to practice our example here. Factor x squared minus 9. So the first thing about factoring using the difference of squares pattern is to make sure that it fits the difference, and it is a difference, of squares, okay? And the first term is x squared. And we know that for difference of squares, we are going to need the square root of that. So what's the square root of x squared? It's just x. And the second term is 9. And what's the square root of that? 3. You could think of it as plus or minus 3, which we do use, but we'll just look at the positive root, which is 3. So that's our b value in the formula. So x squared minus 9 is going to factor to x plus 3, x minus 3. And if you were wondering if that's true, go through, use FOIL, multiply it back, and you'll see. In fact, let's do that. As a check, we're going to multiply. X times x is x squared. X times negative 3 is negative 3x. 3 times x is positive 3x. And positive 3 times negative 3 is negative 9. We have x terms in the center that are the same coefficient, opposite signs, so they will wipe each other out. They're actually equal to 0. And we're left with x squared minus 9, which is the difference of squares. I'm going to let you follow the same pattern and try the next one. Factor x squared minus 49. First, you want to make sure that it does indeed fit the pattern of difference of squares, difference of two values that are squares, and it does. Go ahead, pause the video, and try it out, and then I will catch up. Okay, so this factors to x plus 7, x minus 7. Now sometimes it's helpful to remove a common factor first before you're able to see the square, okay? So actually when I look at this, 2 is not a square, but x squared is. 18 is not a square. But maybe if we remove a common factor first, we may see that we're left with a difference of squares, and it's always worth a try. So let's remove a common factor, and that will be 2, leaving us with x squared minus 9. And there we have it. In the brackets, we have a difference of squares. And so it factors We must remember that we have a 2 there, and it factors into x plus 3, x minus 3. Okay, so in the next example, why don't you pause the video and try this one? Once you come back, I will begin to do it. Okay, I don't see perfect squares. I do see a difference, so perhaps I can treat it as a difference of squares after I factor out a common factor. The common factor is 5, leaving me with x squared minus 25. Now, the square root of x squared is x. The square root of 25 is 5. So this factors into 5 times x plus 5x minus 5. Now lastly, let's see what to do if we want to treat our two terms as a difference of squares when one or both of the terms is not actually a perfect square and there isn't a common factor to factor out. So remember, the formula looks like x, or actually just x squared minus, was it a's and b's? Yes, a squared minus b squared factors into a plus b, a minus b, right? So our first term is x squared, and the square root of that is x. Our second term is 10, and the square root of that is, I'm going to need a calculator for that. However, you know that when I square root 10, it will be many decimal places. So in fact, it's really just better to leave it as root 10. That is its most accurate way of writing it. Okay? So let's leave it as root 10. So that means this is going to factor into x plus root 10, x minus root 10. And that actually works because we can try a check. Let's do a check and multiply it back together using FOIL. X times x is x squared. X times negative root 10 is negative x root 10. And root 10 times x is plus x root 10. And positive root 10 times negative root 10 is negative root 10 root 10. And this becomes x squared. Notice the two terms in the middle are the same, but opposite signs. So they zero each other out. And root 10 times root 10 is 10. So this is subtract 10. So, in fact, it worked. That's all for difference of squares. Thanks for watching.